Okay, so let's continue number 9. And we were at, so we had I exponentiated both sides, e to the natural log of the absolute value of y equals e raised to the natural log of 1 plus x minus the natural log of 1 minus x plus c. So remember I reordered these logarithms in the last part, the first part of number 9. Okay, so the goal again is to solve for this, is to solve for y. Well, this is very nice because, again, e raised to the ln, right, is the identity. So I know that this is just the absolute value of y. And we can use the quotient rule for logarithms to rewrite this guy, right? I can use the quotient rule, right, for logs, right? ln is just a special type of log with base e. So we can rewrite that. So we have e to the ln, the natural log of 1 plus x over 1 minus x. Okay, so when we have subtraction, I'm allowed to rewrite this with a quotient or division. Right? If this was a sum, I would probably multiply these two, but it's not a sum. And we still have our plus c, and I can break this up a little bit more. I can write e to the natural log of 1 plus x over 1 minus x times e to the c. And the reason I rewrote it this way is because, remember, I mean, these have the same base, so we really add these exponents. So these are obviously equivalent. But I rewrote this because I want to write, I know, again, that's going to be 1. And so 1 times all that is 1 plus x over 1 minus x, right? This is a power, so you can use the power rule in logarithms. Your power really comes down, and then this guy, right, again, you can just call this c if you want. If you want to call it k or a, again, it doesn't matter. So let's see. Oops. Let's move this up, and let me just quickly write the property that I used above. So the natural log of a minus the natural log of b, that's the natural log of a over b. Okay, so that's what I used right here. And again, ln is just log base e, right, of some input. And finally, we have, okay, so this is either going to be y or it's going to be negative y. So the question is it going to be y or is it going to be negative y? Well, it depends what function we're working with, and we are working with an exponential function, right? E to the c, e to some power. So e to some power, the kind of generic function, right, looks something like, let's see, I'll try it in blue. Right, there's our exponential function. It's getting closer and closer and closer to this line, right? But it never actually touches 0, right? This is actually the horizontal asymptote, and it grows rapidly, right? This is like your general, y equals e to the x. Well, for every input, I mean, and if I give you an x, your y is always going to be above is going to be positive, right? X input, output is above, again, the x-axis. If I pick a point here, right, it's always here. I pick a point here, my output's going to be here, right? It's never going to be down here. So that's how I know it's not going to be this guy. And so our final solution is y equals 1 plus x over 1 minus x. And if you want to write your constant outside, I think they did. That's supposed to be a c. So this is your solution to the differential equation. Again, general solution, because we weren't given any initial conditions.